Declassified. June 15, 1943. The Mediterranean sun blazed mercilessly down on the crystalline waters off the coast of Sicily, turning the sea into a shimmering mirror that hurt the eyes to look upon. The air hung thick with salt spray and the acrid smell of diesel fuel, while somewhere in the distance, the low rumble of aircraft engines created an ominous backdrop to what should have been a peaceful fishing day. But peace was a luxury that had abandoned these waters months ago, when the Axis powers had turned every inlet, every cove, every fishing village into a fortress of steel and concrete. Lieutenant Commander Marcus "Hook" Harrison crouched behind the weathered gunwale of what appeared to be nothing more than a battered fishing trawler, the Santa Maria, its paint peeling and nets draped artfully to disguise the very real military hardware concealed beneath. The morning light revealed 3 German E-boats cutting through the water like sharks, their sleek hulls throwing up white wakes as they approached at nearly 40 knots. Each boat carried a crew of 14 men, armed with 37mm automatic cannons, multiple machine guns, and enough firepower to reduce Harrison's disguised vessel to splinters in under 3 minutes. The sound of their engines grew louder, a mechanical growl that seemed to vibrate through the wooden planks beneath Harrison's feet. He could feel the sweat trickling down his spine despite the early hour, mixing with the salt spray that occasionally misted over the boat's sides. His hands, calloused from years of handling fishing nets and boat rigging long before the war, now gripped something entirely different, a device that looked like nothing more than an oversized fishing hook attached to a length of steel cable, but which represented months of careful observation, mathematical calculation, and desperate innovation. The German patrol boats had been the scourge of Allied operations in this sector for over 8 weeks. They moved in coordinated wolf packs, appearing without warning to intercept supply runs, attack rescue operations, and harass any vessel that dared venture into what they considered their territorial waters. Intelligence reports indicated that this particular group had already sunk 12 Allied vessels, killing over 200 sailors and Marines. Their tactics were brutally effective: approach at high speed, divide into a triangular formation, and concentrate fire from multiple angles while their superior speed made return fire nearly impossible. What made these particular E-boats even more dangerous was their commander, Captain Lieutenant Friedrich Weiss, a veteran of Baltic operations who had developed a reputation for methodical destruction. His boats never engaged unless they held overwhelming advantage, never stayed in one area long enough for Allied forces to mount an effective response, and never left survivors who might report their position or tactics. The man was turning the Mediterranean shipping lanes into a graveyard, and conventional naval response had proven utterly inadequate. 3 previous attempts to eliminate these boats had ended in disaster. A destroyer squadron sent from Malta had been spotted by reconnaissance aircraft and bombed before they could engage. A submarine ambush had failed when the German boats' shallow draft allowed them to operate in waters too treacherous for Allied subs. Even an airstrike had missed its targets, the E-boat's speed and maneuverability allowing them to scatter before the bombers could achieve effective targeting solutions. Command was growing desperate, casualties were mounting, and the strategic situation was becoming untenable. Harrison watched through his binoculars as the lead boat began to turn, its commander apparently having decided that this lone fishing vessel warranted investigation. The second boat moved to flank from the north while the third took position to cut off any escape route to the south. It was textbook German efficiency, and under normal circumstances, it would mean certain death for anyone aboard the Santa Maria. The range was closing rapidly, 800 yards, 700, 600, and Harrison could now make out individual figures moving on the German decks, their weapons being trained with mechanical precision. But Marcus Harrison was no ordinary naval officer, and the Santa Maria was far from an ordinary fishing boat. Hidden beneath the salt-stained canvas and carefully arranged nets lay the culmination of an idea that had been forming in Harrison's mind for weeks, a concept so simple that it had been dismissed by every naval expert who heard it, so unconventional that it violated basic principles of maritime warfare, and so audacious that it just might work against an enemy who had never encountered anything like it. The approaching German boats represented more than just 3 enemy vessels, they symbolized a type of warfare that was changing the very nature of naval combat. Fast, lightly armored, heavily armed patrol craft were proving more effective than traditional battleships in the confined waters of the Mediterranean. They could strike quickly, inflict maximum damage, and disappear before heavy units could respond. It was guerrilla warfare applied to the sea, and it was winning. As the lead E-boat closed to 400 yards, Harrison could hear the distinctive whine of its engines changing pitch as the commander prepared to reduce speed for the attack run. This was the moment of truth, the culmination of everything Harrison had learned in his 34 years of life, first as a commercial fisherman working the dangerous waters off Nova Scotia, then as a naval officer trying to apply those hard-won lessons to the brutal realities of wartime service. In the next 20 minutes, either his revolutionary approach to naval combat would prove itself, or the Santa Maria would join the growing list of Allied vessels sent to the bottom by Captain Lieutenant Weiss and his deadly efficient crew. The story of how one man's understanding of the sea, combined with the desperate innovation born of wartime necessity, was about to change the course of Mediterranean naval operations forever was about to unfold in these crystalline waters. What happened next would be studied in naval academies for decades to come, not because it followed established doctrine, but precisely because it shattered every conventional assumption about how naval warfare was supposed to be conducted. Marcus Harrison had grown up in the hardscrabble fishing village of Lunenburg, Nova Scotia, where the Atlantic Ocean was both provider and executioner, where men learned to read the water's moods or found themselves beneath its waves. Born in 1909 to a family that had worked these waters for 4 generations, Harrison spent his childhood summers aboard his grandfather's schooner Mary Catherine, learning skills that most naval officers never acquired in a lifetime of service. He understood how currents moved, how wind patterns affected surface conditions, and most importantly, how the ocean could be used as a weapon against those who underestimated its power. His father, Captain William Harrison, had been lost when Marcus was 16, the victim of a sudden November storm that claimed 3 boats and 11 men from their small community. That tragedy might have driven a lesser man away from the sea, but for Marcus it only deepened his respect for the ocean's deadly potential and his determination to master its secrets. He spent the next 6 years working every job available on the waterfront, deck hand, net mender, engine mechanic, and eventually captain of his own vessel, the 30-foot trawler Northwind. It was aboard the Northwind that Harrison developed the unconventional techniques that would later save his life and the lives of countless others. Unlike the larger fishing fleets that relied on brute force and heavy equipment, Harrison learned to work with the ocean's natural forces, using current and tide to position his nets, employing the sea's own movement to his advantage rather than fighting against it. His catches were consistently larger than those of more experienced captains, not because he worked harder, but because he understood the water in ways they did not. The technique that would later become known as Harrison's hook actually originated during a particularly dangerous encounter with a rogue wave in 1936. Harrison had been working alone, hauling in nets during rough weather, when a massive swell threatened to capsize his boat. Instead of fighting the wave directly, he had improvised a solution using his anchor cable and a modified grappling hook, creating a temporary sea anchor that not only prevented capsizing but actually used the wave's energy to pull his boat to safety. The incident taught him a crucial lesson about redirecting force rather than opposing it directly. When Germany invaded Poland in September 1939, Harrison was among the first Canadians to volunteer for naval service, but his unconventional background initially worked against him. The Royal Canadian Navy had little use for a fisherman's intuitive understanding of ocean dynamics. They wanted officers trained in traditional naval doctrine, men who could follow established procedures and execute standard tactics. Harrison's tendency to question conventional wisdom and suggest alternative approaches made him unpopular with instructors who valued conformity over innovation. His first commanding officer, Commander James Thornton, nearly washed Harrison out of officer training after the young Nova Scotian suggested that destroyer tactics against submarine attacks might be improved by studying the hunting patterns of whales. Thornton's report described Harrison as undisciplined, prone to fanciful thinking, and unsuited for command responsibilities. It was only the intervention of Lieutenant Commander Edward Walsh, a veteran of the First World War who had served aboard Q ships, that kept Harrison in the program. Walsh recognized something in Harrison that the other instructors missed, an ability to think in 3 dimensions about naval problems, to see connections between seemingly unrelated phenomena, and to adapt quickly to changing conditions. More importantly, Walsh understood that the coming war would require new approaches to old problems, that the rigid tactical doctrines developed during peacetime might prove inadequate against an innovative enemy. He took Harrison under his wing, teaching him to channel his unconventional insights within the framework of military discipline. Harrison's first operational assignment came in January 1941, when he was posted as executive officer aboard the corvette HMCS Oakville, escorting convoys across the North Atlantic. The Battle of the Atlantic was reaching its peak intensity, with German U-boats sinking Allied shipping faster than it could be replaced. Harrison quickly distinguished himself during several convoy actions, but it was his innovative approach to anti-submarine warfare that first brought him to the attention of higher command. During a particularly savage attack on convoy SC-48, Harrison noticed that successful U-boat attacks seemed to follow predictable patterns based on ocean conditions and convoy positioning. He developed a method of analyzing current charts, weather patterns, and submarine attack profiles to predict where U-boats were most likely to strike. His predictions proved accurate enough that Oakville was credited with preventing 3 separate torpedo attacks and assisting in the destruction of 2 German submarines. The success led to Harrison's promotion to lieutenant commander and assignment to the Mediterranean theater, where the challenges were different but equally deadly. The confined waters, complex coastlines, and presence of land-based aircraft created tactical problems that Atlantic convoy experience did not address. It was here, watching German E-boats systematically destroy Allied shipping, that Harrison began developing the techniques that would make him famous throughout the fleet. The German E-boat problem had reached crisis proportions by the spring of 1943. These fast attack craft, officially designated Schnellboot by the German Navy, were proving devastatingly effective against Allied operations in the Mediterranean. Built for speed and firepower rather than endurance, they could appear without warning, strike hard, and disappear before heavy Allied units could respond. Their shallow draft allowed them to operate in coastal waters where larger ships could not follow, while their speed made them nearly impossible to intercept with conventional surface vessels. Kapitänleutnant Friedrich Weiss commanded the most successful E-boat flotilla operating from bases in southern Italy. His 3 boats, S-102, S-104, and S-108, had been responsible for sinking 12 Allied vessels in the past 2 months, including 2 destroyers, a light cruiser, and 7 cargo ships carrying critical supplies for the upcoming invasion of Sicily. The loss of life had been catastrophic, but perhaps more importantly, the psychological effect on Allied crews was becoming a serious problem. Ships were sailing out of their designated routes to avoid areas where Weiss operated, creating delays and supply shortages that threatened the entire Mediterranean strategy. What made Weiss particularly dangerous was his methodical approach to warfare. Unlike some of his more aggressive contemporaries, he never attacked unless conditions were optimal, never remained in an area long enough for Allied forces to organize a response, and never left survivors who might provide intelligence about his tactics or capabilities. His boats operated with mechanical precision, dividing into attack formations that maximized their firepower while minimizing exposure to return fire. The physical characteristics of the E-boats themselves contributed to their effectiveness. At 115 feet in length and capable of speeds exceeding 40 knots, they were faster than any Allied destroyer and more maneuverable than any vessel large enough to match their firepower. Their armament included a 37mm automatic cannon forward, multiple 20mm anti-aircraft guns, and machine guns positioned to provide overlapping fields of fire. Most critically, they carried 4 torpedo tubes capable of launching the deadly German G-7A torpedoes, weapons that could sink a destroyer with a single hit. Allied attempts to counter the E-boat threat had proven uniformly unsuccessful. Destroyer squadrons sent to hunt them were too slow and too easy to detect, while their deep draft prevented operations in the shallow coastal waters where the German boats typically operated. Submarine patrols were equally ineffective, as the E-boats' high speed and unpredictable patrol patterns made interception nearly impossible. Even air attacks had failed, with the boats' early warning systems and defensive armament making successful bombing runs extremely difficult. The strategic implications were becoming critical. With the invasion of Sicily planned for July, Allied forces could not afford to have their supply lines disrupted by roving E-boat squadrons. Every ship sunk meant fewer supplies reaching the invasion force, every delay meant giving German defenders more time to prepare, and every successful enemy attack boosted Axis morale while undermining Allied confidence. Something had to be done, but conventional solutions had all been tried and found wanting. It was during this period of mounting frustration that Harrison began studying the E-boat problem with the systematic approach he had once applied to understanding fish migration patterns. He spent hours analyzing attack reports, weather data, and navigation charts, looking for the kind of patterns that most naval officers dismissed as coincidence. What he found was that Weiss's seemingly random attacks actually followed predictable cycles based on lunar phases, tide tables, and coastal geography. The German commander was using the sea itself as a tactical advantage, timing his attacks to coincide with conditions that maximized his boat's speed and maneuverability while minimizing the effectiveness of Allied countermeasures. During new moon periods, when visibility was reduced, Weiss operated closer to shore where his boat's shallow draft gave them sanctuary. During full moon phases, he moved further offshore but timed his attacks to coincide with tide changes that would affect Allied vessel handling characteristics. Harrison's analysis revealed something else that other observers had missed. Weiss was not randomly selecting targets but was systematically working to isolate and destroy specific types of Allied vessels. He was targeting repair ships, supply vessels, and communication platforms first, degrading Allied capabilities before moving against warships. It was a sophisticated strategy that demonstrated both tactical brilliance and strategic understanding, but it also revealed a potential vulnerability. The pattern suggested that Weiss would be forced to attack certain types of targets at predictable times and locations. If Harrison could position the right kind of vessel in the right place at the right time, he might be able to turn the German commander's systematic approach against him. The challenge was creating a trap that would appear sufficiently tempting to draw Weiss into an engagement while possessing the capability to destroy his boats once they committed to the attack. This was where Harrison's fishing background provided insights that traditional naval training could not. He understood that successful fishing required thinking like the prey, understanding what would attract them and when they would be most vulnerable. Weiss was a predator, but he was also following predictable patterns, and patterns could be exploited by someone who understood the underlying logic. The solution that began forming in Harrison's mind was audacious in its simplicity and revolutionary in its implications. Instead of trying to outfight the E-boats with superior firepower or outrun them with greater speed, he would use their own tactics against them. He would create a vessel that appeared helpless but was actually deadly, that seemed to follow predictable patterns but was actually setting a trap, and that would turn the ocean itself into a weapon against an enemy who thought they understood its secrets. Harrison's innovation began with a careful study of commercial fishing techniques, particularly those used by vessels working in dangerous waters where speed and stealth were more important than brute force. The method that caught his attention was called long lining, a technique used by deep-sea fishermen to catch large predatory fish by deploying multiple hooks attached to a main line that could extend for miles behind the vessel. The concept was elegantly simple. Instead of chasing the fish, you created conditions that would cause them to chase you, then use their own aggressive instincts to hook them. The military application required significant modification of the basic concept, but the underlying principle remained the same. Harrison envisioned a system that would use the E-boat's high-speed attack pattern against them, creating a situation where their greatest tactical advantage, speed, would become their most serious vulnerability. The key was understanding the physics of high-speed naval maneuvers and how they could be disrupted by carefully placed obstacles. When a vessel traveling at 40 knots encounters an unexpected obstruction, the results are catastrophic. The kinetic energy involved, 1/2 mass times velocity squared, means that even a relatively small obstacle can cause devastating damage. Harrison calculated that a steel cable deployed at the right angle and tension could not only stop an E-boat but could actually tear it apart, using the vessel's own momentum as the destructive force. The challenge was deploying such a cable system without alerting the enemy to the trap. The technical solution required 3 separate components, each carefully engineered to work in conjunction with the others. The first component was the deployment system, a modified winch mechanism disguised as fishing equipment that could rapidly deploy heavy steel cable behind the vessel. The winch had to be powerful enough to maintain tension on the cable under extreme loads while being fast enough to deploy the full length of line in under 90 seconds. The second component was the cable itself, but not ordinary maritime cable. Harrison designed a system using aircraft arresting cable, the same type used on aircraft carriers to stop landing planes. This cable was specifically engineered to absorb massive kinetic energy without breaking, but when properly anchored, it could transfer that energy back to whatever struck it. The cable was weighted at regular intervals with lead sinkers to keep it at the proper depth, shallow enough to catch the E-boat's hulls but deep enough to remain invisible from the surface. The third component was perhaps the most ingenious, a series of breakaway anchors that would release under extreme tension, allowing the cable to move with the striking vessel while maintaining enough resistance to cause critical damage. These anchors were designed to fail in sequence, creating a progressive braking effect that would maximize damage to the enemy vessel while preventing the cable from snapping under the initial impact. The complete system could be deployed from what appeared to be nothing more than an ordinary fishing trawler, using equipment that looked authentic enough to pass casual inspection. The key was making the deployment process appear routine, so that enemy observers would see nothing more threatening than a fisherman setting his nets. Harrison spent weeks practicing the deployment procedure until his crew could have the entire system in place and ready within 3 minutes of receiving the order. Testing the system required absolute secrecy and carefully controlled conditions. Harrison conducted initial trials using unmanned target boats traveling at various speeds, gradually increasing velocity until he could predict with mathematical precision how the cable system would affect vessels traveling at E-boat speeds. The results exceeded his most optimistic projections. A target traveling at 35 knots was completely destroyed when it struck the cable array, the impact transferring enough energy to break the vessel's keel and scatter debris over a quarter-mile radius. The physics involved were both elegant and devastating. When the E-boat struck the cable, the initial contact would occur at the bow, where the vessel's hydrodynamic design concentrated all forward momentum into a narrow point. The cable would resist this force, creating a fulcrum effect that would lift the bow while the boat's own speed drove the stern forward. The result would be a catastrophic structural failure that would break the vessel's back, flooding the engine compartment and rendering the boat helpless within seconds. What made the system even more effective was its scalability. Harrison designed the cable array to be deployed in multiple parallel lines, creating a network of obstacles that would be virtually impossible for high-speed vessels to avoid. An E-boat attempting to evade one cable would almost certainly strike another, while the spacing of the array meant that even if the first vessel managed to avoid the trap, following boats would have no time to react. The final innovation was the recovery system, which allowed Harrison's crew to quickly retrieve the cables after a successful engagement. This capability meant that the weapon could be used repeatedly, and more importantly, it ensured that enemy forces would find no evidence of the trap after the engagement was complete. To any investigation, it would appear that the E-boats had simply suffered catastrophic mechanical failures or had struck uncharted obstacles. The technical elegance of the system was matched by its tactical flexibility. The cable array could be deployed in advance of an expected engagement, allowing Harrison's vessel to maintain the appearance of routine fishing operations right up until the moment of contact. The enemy would have no indication that they were approaching a trap until they were already committed to the attack run, at which point their own speed would prevent any evasive action. Command approval for the operation came only after Harrison demonstrated the system's effectiveness during a carefully staged exercise. Even then, many senior officers remained skeptical about the unconventional approach. Admiral Sir Andrew Cunningham himself reviewed the proposal, ultimately approving it not because he was convinced it would work, but because conventional methods had so clearly failed. In his words, the Mediterranean situation was desperate enough to justify any innovation that might conceivably succeed where traditional tactics have not. Harrison was given command of the disguised trawler Santa Maria and a hand-picked crew of volunteers, each sworn to absolute secrecy about their mission. The vessel was extensively modified to carry the cable deployment system while maintaining its appearance as a working fishing boat. Every detail was carefully considered, from the arrangement of nets and equipment on deck to the type of fish scales scattered in the hold. The deception had to be perfect, because a single suspicious detail could alert the enemy and doom the entire operation. The morning of June 15, 1943, dawned clear and calm, with unlimited visibility and light winds from the southeast. Harrison had positioned the Santa Maria exactly where his analysis predicted Weiss would appear, timing the operation to coincide with optimal tide conditions and the new moon phase that would provide maximum concealment for the cable deployment. Everything was ready, the crew was at battle stations disguised as fishing positions, and the revolutionary weapon that could change the course of the Mediterranean war lay hidden beneath innocent-looking fishing gear, waiting for its first test against a real enemy. At precisely 0847 hours, the lookout spotted three dark shapes on the southern horizon, moving fast and in formation toward their position. Captain-Lieutenant Friedrich Weiss was coming, and he was bringing exactly the force that Harrison's calculations had predicted. The trap was set, the prey was approaching, and in the next 20 minutes, naval warfare would be changed forever. The morning sun climbed higher as the three German E-boats closed the distance, their powerful engines creating a distinctive harmony that experienced sailors could identify from miles away. Harrison checked his watch, 0852 hours, and gave the subtle hand signal that initiated the cable deployment sequence. To any observer, it would appear that the fishing crew was simply setting their nets for the day's work, but in reality, they were laying out nearly 2,000 yards of aircraft-grade steel cable in a carefully calculated pattern that would turn the approaching vessel's speed into a weapon against themselves. Petty Officer Thompson, a former commercial fisherman from Newfoundland who understood the deception better than anyone, worked the modified winch with practiced efficiency while maintaining the unhurried pace of a man who had been setting nets since childhood. The cable paid out smoothly, its lead weights carrying it to the predetermined depth of 8 feet, shallow enough to catch the E-boat's hulls but deep enough to remain invisible from the surface. Behind him, 3 other crew members played their roles perfectly, arranging nets and equipment to conceal the cable guides while keeping their apparent attention focused on routine fishing tasks. Harrison maintained his position at what appeared to be a chart table but was actually the control station for the entire system. From here he could monitor the cable tension, track the deployment progress, and most critically, activate the emergency release system if something went wrong. The approaching E-boats were now close enough that he could make out individual details through his binoculars, the spray patterns from their bows, the antenna arrays on their bridge structures, even the movement of personnel on their decks. The lead boat was maintaining course and speed, indicating that Weiss had decided this lone fishing vessel warranted investigation but posed no immediate threat. This was exactly what Harrison had hoped for. The German commander was following his standard tactical pattern, approaching with confidence born of countless successful encounters with helpless prey. The second and third boats were taking flanking positions, preparing to cut off any escape routes while the leader moved in for the kill. At 0855 hours, with the range down to 600 yards, Harrison could clearly see the 37mm cannon being traversed toward his vessel. In 60 seconds, that gun would open fire, and the Santa Maria would join the growing list of Allied vessels sent to the bottom by Weiss and his crew. But Harrison's cable array was now fully deployed, stretching in 3 parallel lines across the Germans' approach path like an invisible net designed to catch sharks instead of fish. The physics of what happened next occurred exactly as Harrison's calculations had predicted, but the visual reality was more spectacular than anyone aboard the Santa Maria had imagined. The lead E-boat, S-102, struck the first cable at exactly 0856 hours while traveling at 38 knots. The impact point was precisely where Harrison had calculated it would be, at the waterline just forward of the engine compartment, where the hull's hydrodynamic design concentrated the vessel's forward momentum into the narrowest possible area. The steel cable, under tremendous tension from the boat's own speed, acted like a giant cheese wire drawn across the E-boat's hull. The initial contact created a shower of sparks as steel met steel, followed immediately by the sound of tearing metal as the cable sliced through the vessel's plating. The boat's own momentum drove it forward onto the cable, which penetrated deeper with each fraction of a second, while the tremendous resistance created by the impact began to lift the bow clear of the water. S-102's crew had perhaps 3 seconds to understand what was happening before their vessel literally broke apart beneath them. The cable's resistance created a fulcrum effect at the point of contact, causing the bow section to rise while the stern, driven by the still racing engines, continued forward. The structural stresses involved exceeded the boat's design limits by an order of magnitude, and with a sound like thunder, the vessel's keel snapped approximately amidships. Water rushed into the destroyed engine compartment with devastating force, while the bow section, now completely separated from the rest of the vessel, cartwheeled through the air in a spray of debris and fuel. The stern section, its engines suddenly racing without load, spun wildly for several seconds before the flooding reached the engine compartment and the diesel motors died with a mechanical scream. From initial impact to complete destruction, the entire sequence took less than 15 seconds. Captain Lieutenant Weiss, commanding the second boat, S-104, had just enough time to register the destruction of his lead vessel before his own boat struck the second cable line. His helmsman's attempt to swerve away from the disaster ahead only ensured that S-104 hit the cable at a slight angle, which paradoxically made the damage even more severe. Instead of a clean cut, the angled impact caused the cable to tear along the vessel's length like a giant saw, opening the hull from stem to stern. The effect was catastrophic. S-104 didn't break apart like its predecessor. Instead, it simply opened like a flower, its sides peeling away from the destroyed keel while the sea rushed in through a rent that extended almost the entire length of the vessel. Weiss himself was thrown clear by the impact, his last conscious thought being the realization that he had led his flotilla into a trap more sophisticated than anything he had encountered in 4 years of naval warfare. The third boat, S-108, managed to avoid the cable array but not the consequences of its deployment. Her commander, seeing the destruction of both lead vessels, threw his engines into reverse while attempting a sharp turn to starboard. The violent maneuver at high speed caused the boat to broach, turning sideways to its own wake, and the combination of reverse thrust and lateral water pressure flipped the vessel completely over. S-108 capsized within sight of her sister ships, her crew trapped beneath the overturned hull or scattered in the water around the wreckage. From the bridge of the Santa Maria, Harrison watched the destruction with a mixture of professional satisfaction and human horror. In less than 3 minutes, 3 of the most feared vessels in the Mediterranean had been eliminated, not by superior firepower or technological advantage, but by turning their own tactical doctrine against them. The speed that had made them virtually invincible had become the instrument of their destruction, while their aggressive attack pattern had driven them directly into a trap they never suspected existed. The immediate tactical situation required quick action. 17 German sailors were in the water, some wounded, all requiring rescue according to the laws of maritime warfare. But Harrison also had to consider the strategic implications. If word of this engagement reached German command, the innovative tactics that had proved so effective would be countered, and the advantage would be lost. The solution he chose reflected both his humanitarian instincts and his understanding of military necessity. Harrison ordered the Santa Maria to move toward the survivors while his radio operator sent a coded message to Allied command: fishing successful. 3 large catches. Returning to port with cargo. The message would be understood by those who needed to know while remaining meaningless to any German signals intelligence that might intercept it. Meanwhile, his crew began the dangerous work of retrieving survivors from water that was rapidly becoming contaminated with diesel fuel and floating debris. The rescue operation took 47 minutes and resulted in the recovery of 11 German sailors, including Captain Lieutenant Weiss, who had survived his vessel's destruction with a severe concussion and multiple lacerations. The remaining 6 crew members were presumed lost, their bodies either trapped in the wreckage or swept away by the current. Harrison ordered his men to provide full medical attention to the survivors, both from humanitarian considerations and because intelligence value of captured enemy personnel could prove significant. As the Santa Maria headed toward the Allied base at Malta, Harrison had time to consider the broader implications of what had just occurred. The tactical success was undeniable, 3 enemy vessels destroyed without a single Allied casualty, but the strategic ramifications would depend on how effectively the new technique could be adapted and deployed. The cable system had worked perfectly, but it was essentially a one-time weapon that would lose effectiveness once enemy forces understood and adapted to it. The after-action report filed by Harrison upon his return to Malta would eventually become required reading at naval academies throughout the Allied nations, not because it described conventional tactics executed with superior skill, but because it demonstrated how creative thinking applied to military problems could achieve results that traditional approaches could not. The Harrison hook, as it quickly became known throughout the fleet, represented a new category of naval weapon, one that used the enemy's own capabilities as the source of destructive power. Within weeks of the engagement, modified versions of Harrison's cable system were being installed on vessels throughout the Mediterranean fleet. The basic concept was adapted for use against submarines, surface raiders, and even aircraft in some applications. Engineering teams worked to refine the deployment mechanisms, improve the cable materials, and develop tactical doctrines for employing the new weapon system under various conditions. The psychological impact on German naval operations was immediate and profound. The complete disappearance of Weiss's flotilla, combined with the lack of any apparent cause for their destruction, created uncertainty and caution where there had previously been confidence and aggression. E-boat operations in the Mediterranean became noticeably more conservative, with commanders avoiding the kind of aggressive tactics that had made them so effective. This change in enemy behavior was, in many ways, more valuable than the destruction of the 3 boats themselves. The broader legacy of Harrison's innovation extended far beyond its immediate tactical applications. The engagement demonstrated that naval warfare, like all forms of military conflict, was subject to revolutionary change when creative minds were applied to seemingly intractable problems. Traditional assumptions about the relationship between speed, firepower, and tactical advantage had to be reconsidered in light of what had occurred in those crystalline Mediterranean waters. For Harrison himself, the success brought immediate recognition but also the burden of command responsibility that came with proven capability. He was promoted to full commander within a month of the action and given command of a flotilla of specially equipped vessels tasked with continuing the development of unconventional naval tactics. His understanding of the sea, honed through years of commercial fishing, had proved invaluable in military application, and Allied command was determined to exploit that knowledge to its fullest extent. The final irony of the engagement was that it succeeded not by overwhelming enemy forces with superior technology or firepower, but by understanding and exploiting the natural laws that governed their behavior. Harrison had applied the same observational skills and pattern recognition that made him successful as a fisherman to the problem of naval warfare, with results that no conventional military education could have predicted. It was innovation in its purest form, the application of existing knowledge to new problems in ways that revealed previously unknown possibilities. Commander Marcus Harrison received the Distinguished Service Order for his actions on June 15, 1943, but characteristically, he deflected most of the credit to his crew and to the circumstances that had allowed the innovation to succeed. In his acceptance speech, delivered at the Royal Naval College in Portsmouth after the war's end, he emphasized that creativity in military affairs was not a substitute for traditional training and discipline, but rather a complement to them, a way of applying established principles to new situations that conventional doctrine had not anticipated. The post-war years found Harrison returning to his roots, both literally and figuratively. He resigned his commission in 1946 with the rank of captain and returned to Nova Scotia, where he purchased a small boatyard specializing in custom vessel design. His clients included both commercial fishermen seeking more efficient boats and government agencies requiring specialized craft for various purposes. The innovative spirit that had served him so well during the war continued to drive his civilian career, resulting in several patents for marine equipment and recognition as one of Canada's leading naval architects. Harrison married Margaret Sinclair, a nurse he had met during his recovery from wounds sustained in a later Mediterranean action, and they raised 3 children in the same Lunenburg community where he had learned his first lessons about the sea's power and unpredictability. He rarely spoke publicly about his wartime experiences, preferring to focus on the future rather than dwelling on past glories. When pressed by historians or journalists, he would typically deflect questions about his innovations by insisting that necessity, rather than genius, had been the mother of his inventions. The Harrison Boatyard became a pilgrimage site of sorts for naval officers and marine engineers who wanted to understand how unconventional thinking could be applied to maritime problems. Harrison was always gracious with such visitors, but he consistently emphasized that innovation was not a mysterious process accessible only to specially gifted individuals. Instead, he argued, it was the natural result of careful observation, systematic analysis, and willingness to challenge assumptions that others took for granted. His teaching methods, developed through years of working with young apprentices at the boatyard, emphasized hands-on experience combined with theoretical understanding. Students learn to read water conditions, understand the relationship between design and performance, and most importantly, to think independently about problems that had conventional solutions but might benefit from fresh approaches. Several of his apprentices went on to distinguished careers in naval architecture, carrying forward the innovative spirit that Harrison had demonstrated during the war. The Harrison hook technique itself was declassified in 1963 and became part of standard naval warfare curricula at military academies worldwide. However, the specific tactical applications were considered less important than the broader lesson about adaptability and creative problem-solving under pressure. Military historians noted that Harrison's success demonstrated the value of diversity in military leadership, how perspectives gained outside traditional military channels could provide insights that conventional training might miss. Harrison's health began declining in the early 1980s, the result of exposure to diesel fumes and other industrial chemicals during his years at sea. He faced the diagnosis of emphysema with the same quiet determination that had characterized his approach to wartime challenges, continuing to work at the boatyard until shortly before his death. His final project was the design of a small sailing vessel intended for disabled veterans, incorporating features that would allow individuals with various physical limitations to experience the freedom and challenge of sailing. He died peacefully at his home overlooking Lunenburg Harbor on March 12, 1987, surrounded by family and with a view of the waters that had shaped his life and career. The funeral drew hundreds of mourners, including former crew members, naval officers, fishing industry representatives, and government officials who recognized his contributions to both military and civilian maritime development. The eulogy, delivered by Admiral Sir John Fieldhouse, emphasized that Harrison's greatest achievement was not any single innovation, but rather his demonstration that creative thinking could overcome seemingly insurmountable challenges. The Marcus Harrison Memorial Foundation, established by his family and former associates, provides scholarships for young people pursuing careers in marine sciences and naval architecture. The foundation's motto, taken from Harrison's own words, reads, "The sea teaches all who listen, but only those who think differently can hear its most important lessons." Annual awards recognize innovations in maritime technology that demonstrate the kind of creative problem-solving that Harrison exemplified throughout his career. Modern naval doctrine still includes elements derived from Harrison's wartime innovations, though the specific techniques have evolved considerably with advances in technology and changes in tactical requirements. The fundamental principle, using an enemy's strengths against them through careful preparation and unconventional tactics, remains relevant in contemporary military planning. War colleges worldwide use the Mediterranean engagement as a case study in innovative thinking under pressure, emphasizing how individual creativity can influence strategic outcomes. The physical memorials to Harrison's achievements are modest, reflecting his preference for practical utility over grandiose recognition. A small plaque at the Lunenburg waterfront marks the site of his boatyard, while the Naval Museum of the Atlantic in Halifax maintains an exhibit describing his wartime service and post-war contributions to marine technology. The exhibit includes detailed technical drawings of the cable deployment system, survivor accounts of the June 15 engagement, and examples of the civilian innovations that grew from his military experience. Perhaps the most fitting memorial is the continued use of Harrison's approach to problem-solving in maritime contexts ranging from commercial fishing to naval warfare to marine rescue operations. His insight that the ocean could be used as a weapon against those who underestimated its power has been applied in countless situations where conventional solutions proved inadequate. The principle of turning enemy strengths into vulnerabilities remains a cornerstone of asymmetric warfare doctrine, while his emphasis on observation and pattern recognition continues to influence naval training programs worldwide. The ultimate lesson of Marcus Harrison's life and career was not that any individual innovation, however brilliant, could single-handedly change the course of warfare. Rather, it was that the application of diverse perspectives, careful observation, and willingness to challenge conventional wisdom could reveal possibilities that traditional approaches might never discover. In 20 minutes on a clear Mediterranean morning, one man's understanding of the sea's power transformed the tactical balance in a critical theater of operations, proving that innovation and tradition, properly combined, could achieve results that neither could accomplish alone. The numbers tell the story with stark clarity: 3 enemy vessels destroyed, 17 enemy personnel captured, 0 Allied casualties, and a strategic shift in Mediterranean naval operations that contributed directly to the success of the Sicily invasion. But behind those numbers was a more profound achievement, the demonstration that human creativity, properly applied, could overcome seemingly insurmountable odds and change the course of history itself.